I'm going to break this presentation into 4 sections. One is just a quick introduction to Coventry Chemicals, a little about our history and the company. Second is actually looking at disease challenge and biosecurity and the importance of it. We'll talk a little about some key products, Omnicide and Omniclean, and then go through an example of biosecurity best practice for terminal disinfection. So, Coventry Chemicals. We've been around for quite a while. Originally formed as William Pearson in 1880. The company developed creolin, hycolin, some of the original phenolic disinfectants. Coventry Group itself acquired William Pearson in 1994 and has had a couple of rebrands along the way. So we have Mirius, which is our professional and retail division. Company is made up of about 185 skilled and professional employees. We also have some additional warehouse and other people within the group. So, quick overview of the core team. We work to very high accreditation standards and try to keep up with both best practice, ISO standards, and also good sustainability standards such as Sustainable Palm Oil Initiative and many others. The site itself is registered under GMP, so the entire site is operating to full good manufacturing practice, ensuring we are producing to the highest possible standards. We're very proud of our track record. We've achieved a lot of awards over the years. One I'm personally very pleased about is the Queen's Award for Enterprise, which we received in 2021. This is in the international trade, and that's a recognition, I think, of many years of hard work for everybody in the company. So, disease challenges. We've got a wide variety of different pathogens out there: bacteria, viri, fungi, parasites. All of them have the potential to be pathogenic. Each is unique. They have their own characteristics, their own life cycles. And we have to do our very best to combat those and protect livestock from them. So, we also have to remember that while we know and have good knowledge of many pathogens, there are always new pathogens emerging and some old ones that we've forgotten about returning to us. We see this quite often with long forgotten diseases coming back into the pig sector, into the poultry sector, becoming again a challenge to the industry. The life cycle of disease is in 4 parts. So we have an entry phase, a replication phase. This can be with or without visible symptoms, an exit phase, and finally a persistence in the environment. So, where do we work with biosecurity? The main objective is to try and break here and here. We're trying to prevent the disease either entering a farm or where it's exited, we're trying to break it down in the environment and stop it from spreading from animal to animal or from site to site. Biosecurity is very much the foundation of this. If we look at our pyramid here, we have 3 levels: biosecurity, preventatives, and curatives. With biosecurity, we're focusing on prevention of disease entry. We have the preventative things, vaccinations, and biosecurity will very much support those processes. At the top end, we have the curative phase. This is putting antibiotics in or other veterinary interventions. The top phase here is without doubt the most expensive. This is very good, and here we can put a lot of investment in, both to support and drive better practice in the. So, when we talk about disease, I often think the iceberg is a very good analogy for what we see. At the very tip, we see severe disease. This is when we've had a major outbreak. We have to get the vet out, we prescribe medicines. We could be looking at major mortality within a flock or herd. Clinical disease, again, serious symptoms, we must medicate. Below that, we have subclinical disease and also exposure without noticeable infection. These two latter categories often pass almost unnoticed. We may see small depressions in performance. We may, if we're monitoring our flocks very carefully, we may see our FCRs falling. That's the feed conversion ratio. We may see other indications. We may see reduced quality of eggs or reduced egg production. We may see slower growth cycles. All of these things can be seen, and all of them are causing economic loss to us as an industry. So, what can we do about it? Well, if we look at two key products, Omniclean and Omnicide. These are two products that we produce at Coventry Chemicals. Omnicide itself goes back to 1965. We were the original developers of the glutaraldehyde quaternary disinfectants, and we've had a lot of time to develop those products over the years, improve it, refine it, and get a better understanding of those type of products and how they're used. So, the question is though, why clean and disinfect? And I think this is one of the things that is often missed. The cleaning stage is absolutely critical to maintaining good biosecurity. If we take a typical example here, we've got theoretically 10 trillion bacteria on a wall. If we go in, we mechanically remove debris, litter, we can reduce that quite significantly. So from 10 to the 9th down to 10 to the 7th. We can soak the surfaces, we can remove visible dirt from the surfaces, and we can get further improvements. We bring in a cleaner and a detergent, we can get right down to 10 to the 6th, so 1 million bacteria on a surface. By that point, the surface is visually clean, and this is the ideal time then to employ a disinfectant. It's very important to realize that disinfectants are designed to work on clean surfaces. If we apply a disinfectant to heavily contaminated surfaces, we are not going to see the benefit of the disinfectant. I often go onto farms and observe people who clean out in a very simplistic way. They don't use a detergent, they just spray the surfaces down. They then put the disinfectant on. It's not magic. It's a chemical. It will do a very good job of reducing the pathogens on surfaces, but you must present the right surface to it, and you must also give it the best chance of working by doing that. So at the end, after we've gone through all these stages, we hopefully get down to around 100 bacterial cells per square meter or per centimeter on a surface. That's a good level. It's not the level you're going to find in a food factory or an operating theatre. They would go for much lower levels. But on a farm where we have lots of complex surfaces, we have concrete, we have wood, we have painted metals, some of these surfaces can harbour bacteria and viral particles very easily, but we take all the steps we can to limit the amount of remaining bacteria at the end of the cleaning cycle. So to talk a little more about Omniclean itself, it's actually a very high foaming product. We often recommend that the product's applied with a foaming lance, which allows you to maximize the contact time, particularly on vertical surfaces. If it's simply sprayed on, it will come off the walls quite quickly, and you're not getting the full benefit of the product. So foaming it on is the very best way to use a cleaning product such as this. It's quite versatile. We designed the product specifically so it can be used on a multitude of surfaces. It can be used for cleaning both walls, floors. It can also be used on equipment, so your feed tracks and other areas around the farm, because it's a relatively low caustic content. But it still will perform extremely well. We've developed it as well to be compatible with the Omnicide product. And this is an area that is often overlooked. The interaction between remaining amounts of cleaner on a surface and the disinfectant. If the two are not built to work together, you can very often get situations where you start to inactivate the disinfectant. You get residual ions that will react with glutaraldehyde in particular and significantly reduce its effectiveness. So when we design the cleaner, we designed it specifically to work with Omnicide and not interfere with the function of the disinfectant. You can see here a nice little illustration of the product being applied to a floor surface. We have taken great care with the product to make sure it's not going to stain surfaces, it's not going to damage surfaces. One of the worst things you can do is apply a very aggressive cleaner and create pitting in surfaces, because the more you create that pitting and cracking on surfaces or corrosion, you're creating a safe harbor for bacteria and other pathogens to hide. So you don't want to damage those surfaces that you're cleaning. You want to strip away all the fats, all the residues, but leave the surface pristine and unharmed. The other thing to note about using a cleaner, you can significantly reduce the time it takes to clean. The process of cleaning without using a good detergent is very labor intensive. You've got to spray, you've got to scrub, you've got to spray again. With a cleaner applied properly, you can do your initial mechanical clean down and then go in with the cleaner, spray it onto the surface, allow it some time to work, and then wash it away and leaving your pristine surface. So typically you can reduce the time between 30 to 60% depending on the environment you're working in. It's particularly noticeable where you've got complicated environments such as cage units where you've got a lot of different surfaces. It's very difficult to work around those with mechanical cleaning processes. You need a good chemical-based cleaner to get all those surfaces properly cleaned. So, to turn to Omnicide, I mentioned already that this is the Omnicide brand was the original glutaraldehyde quaternary disinfectant. We've kept the name over the years. The product has certainly evolved and changed, and we've had a lot of time to study this and optimize it. There are two key components, the cocobenzyl dimethylammonium chloride and the glutaraldehyde. The two together actually perform far better than either one in isolation. There is what we call a synergistic effect of using these two components. This is particularly noticeable when we look at gram-negative bacteria, and is also very noticeable when we start looking at fungi and other difficult-to-kill organisms. The product has been used for many, many years, and it's been independently tested for just about every species of animal you can think of throughout the world. We have worked with people producing poultry, right through to people raising crocodiles, camels, and other interesting exotic species in many places. So we've had a lot of time to work on this. It's been proven to be highly effective against all known zoonotic pathogens. It's very effective at low temperatures and has some of the highest approval rates in the industry. We've also done a lot of research on residual activity for the product and have some data to show that the product does remain active for an extended period after application. The formulation is also non-corrosive, and this is a very important point that's often overlooked when we talk about disinfectants. We routinely use disinfectants on vehicles and other machinery with delicate parts made of aluminium, copper, rubber. These things do not react well to aggressive chemicals. One of the observations we've often seen where wheel dips and other mechanisms have been used with certain chemistries, when you examine the underside of the vehicles after a few months of use, the amount of corrosion on the vehicles is very considerable. And it's, again, back to that problem, A, damage to the vehicle itself, and B, you're providing a surface which is much more amenable to the attachment of bacteria and debris in general. I mentioned formaldehyde because formaldehyde has been used in the poultry industry for a very long time. It works very well if used in the right way, but there's always a concern about safety. Glutaraldehyde is a much safer alternative. So, considering glutaraldehyde, there's a lot of different sources around the world of glutaraldehyde, but the quality varies considerably. We've worked with Dow, one of the biggest producers in the world, for a very long time. We've also had a relationship with BASF, and what we've discovered is quite concerning. Samples of glutaraldehyde purchased from sources globally, I'm not going to name specific countries or specific sources, but many times we've found as much as 25 or even 50% formaldehyde, glyoxal, methanol in these glutaraldehyde sources. And that has a serious effect for two reasons. One, these materials do not have the efficacy of glutaraldehyde. And two, you have the safety concerns again, if we think of, in particular, of formaldehyde. Why do they do it? Well, it's quite cheap to produce formaldehyde. And if you're using simple testing practices, normal wet chemistry, you can't tell whether you're looking at formaldehyde and glutaraldehyde blended or pure glutaraldehyde. There are techniques that can do it. HPLC, which is high pressure liquid chromatography, we can identify exactly what we're looking at. We can see that we've got pure glutaraldehyde or glutaraldehyde that is mixed with other things. To be absolutely clear, we only use glutaraldehyde sourced from Dow or BASF. I'm going to show a couple of examples of just how big a difference there is in the effectiveness of a real glutaraldehyde with some of the, shall we say, counterfeit or less than perfect glutaraldehyde sources. We've got here 4 standard agar plates, and these have been seeded, in this case, with Salmonella bacteria and allowed to grow after exposure to 4 different things. The first one, the control, is pure water. We wouldn't expect to have any reduction in the count at all. What you can see there, the plate is absolutely covered in bacteria. You couldn't count the colonies. If we look at formaldehyde, yeah, there is quite a significant effect, but still, there's a lot of colonies there. There's far too many to count. Turning to the counterfeit glutaraldehyde, it has worked, but still hundreds and hundreds of colonies on that plate. Finally, we look at the real glutaraldehyde, just 19 colonies. E. coli, another common bacteria, we see the exact same thing again. The genuine glutaraldehyde, we only have 4 viable colonies. Looking at the others, we're seeing far too many colonies to count. Now, turning to the other half of the formula, the cocoa quat. Now, the cocoa quat is unique. There are a lot of different quaternary ammonium chlorides in the market. Each different one works slightly differently. The different carbon chain lengths from 8 carbons up to 18 carbons have slightly different interactions with their bacterial cells and other cell structures. We know that the shorter chain lengths are very effective against lipophilic viruses and gram-positive bacteria, but the longer chain lengths, the 16 and 18 carbon chains, have significantly increased activity against gram-negative bacteria and provide far greater efficacy overall. As you can see, quick demonstration, the evolution of quaternary compounds from the very oldest, benzalkonium chloride, through ADBAC, didecyl, dimethyl ammonium chlorides, the longer chain ones, and various other blends. What we have here is the distribution of the most common. DDAC, which you will see used in many products, benzalkonium chloride, which you'll also see, this is in the green, and finally the cocoa QAC, which we use. What you'll notice is the cocoa QAC covers the full range of chain lengths, whereas even if you combine DDAC and BKC together, you're still very limited in the C16 and C18 chain lengths. And that means that you don't have the same level of efficacy. To back up some of this, we've tested against more than 70 strains of bacteria using labs from around the world. I've just picked out a few test results to show the effectiveness of the product. All of these tests have been done at 10 degrees centigrade or lower, so they've been done in quite cold conditions. And it's worth mentioning that the effectiveness of virtually all disinfectants is temperature dependent. The colder it gets, either the longer you've got to leave the disinfectant on a surface, or the more disinfectant you've got to use. The same applies with soiling. The more soiling you've got, you need to give it longer to work, or you've got to give it a lot more disinfectant to overcome the soiling effects. So here we have Listeria, Proteus mirabilis, Clostridium perfringens, Salmonella typhon, Mycoplasma gallopspectrum, all of these quite significant pathogens in various sectors. Not all poultry related, we have pig dysentery and others. But what we have consistently is very good efficacy. We achieve a 4 log reduction, that's 99.99% or greater at the dilutions that I've indicated there. So typically 0.5%, sometimes very much less than 0.5%. Turning to viruses, again, I've just picked out a few. We've tested around 30 viruses, and we continue to invest in testing against new and emerging challenges to ensure the efficacy of the product. So we have infectious bursal disease, we have IBV, herpesvirus, Newcastle disease virus, avipox, rotavirus. All of these, again, performing very, very well. Some of them quite difficult to kill. We have to consider that some viruses are significantly more challenging to disinfectants, particularly those that are what we call a non-enveloped virus. So these are the very small capsid viruses, and as a general rule of thumb, the smaller the capsid, the more difficult the virus is to kill. You could consider poliovirus is probably one of the smallest virus particles that exists. It is also one of the most difficult viruses to kill. At the other end of the spectrum, if we look at large envelope viruses, which I often refer to as floppy envelope viruses, they're very big particles. They have a nice lipid envelope around the viral particle, and those are very easy to break and destroy. Of all of these, you'll notice there rotavirus is the one that's most difficult to kill here, and that is indeed a small non-envelope virus. Just to pick up some other very important viruses across other species, African swine fever virus, which has caused so much trouble, particularly out in Asia. We have testing against both the commonly found isolate and also the Chinese specific isolate, which we had done at the state labs there. Swine vesicular disease, H1N1, bovine enterovirus, vaccinia, PEDV, all different viral challenges covering a multitude of species. Finally, I'm just going to mention DEFRA. DEFRA is the state authority in the United Kingdom, where I come from. For many, many years, they've maintained their own testing program, which is done in the government labs. Because of the environmental conditions in the UK, we have very cold temperature. They test at 4 degrees C, which is a very low temperature. Again, as I mentioned earlier, that poses quite a challenge for disinfectants. They also test at a very, very high organic load, so the absolute worst case you could possibly create for a disinfectant to work in. The numbers you're seeing, the dilutions might look low, but bear in mind those facts. You are talking about low temperatures, relatively short contact times. They only allow 30 minutes contact time, which is far less than you would typically see on a farm. And they're challenging with very high soiling levels. The approval rates we have here are the best in the industry. You won't see any gluquat disinfectant achieving better than 1 to 90 under these test conditions. You can independently verify this. You can go on to DEFRA's website where they publish all the results for all the disinfectants in the market that are approved for use in the UK. And you can see for yourself that the Omnicide result is the best in the market and has been for as long as the tests have been run. The other point to the DEFRA tests is this is also the scheme that marks the approval of a disinfectant for use after a disease outbreak. And that's a very important point. These test results are backed up by real-world experience. We've had some very major disease outbreaks in the UK. We had foot and mouth disease going back into the 80s, which decimated the cattle populations. Omnicide was used heavily by DEFRA for remediation of farms. And at that point, we actually found ourselves under a state order and had to sell basically 100% of our product to the government while they worked through the process of putting the cattle farms back in action. It was a tough time for the industry, but a statement, I think, to the effectiveness and the faith that they had in Omnicide to achieve results. Avian influenza is another major challenge we face. Every year we have migratory bird populations that come across from Eastern Europe, and almost you can mark the day on the calendar when the first avian influenza cases will start to break across the country. So it's a very major challenge. Again, we've been asked by the government to provide Omnicide in large quantities when these outbreaks occur. And this is a very important, I think, point to make, that they trust us to produce the product and they trust the results that it gets. I mentioned earlier about residual activity. And this is quite a unique thing for a glutaraldehyde-based disinfectant. It's mainly to do with the additional components we put into the formula, but we have demonstrated very effectively that we have significant residual action after the disinfectant is applied to a surface. You can see there the target organisms and the exposure times that were tested. So these are the results we got. From day 1 to day 7 after application of the disinfectant, we saw no growth at all on the surfaces. Day 8, yes, you're starting to see a little growth. 9, 10, you're definitely seeing some growth. But this is very important because it means that after you've used Omnicide in your poultry building or other equipment, you've got a measure of protection. The time between cleaning and you tipping your chicks or populating your cages, you have protection, and because of that, at the point where those young and quite immune vulnerable animals are introduced to their new environment, they are coming into an environment that should be free of pathogens and therefore have the best possible chance to thrive. I've put a rather large table up here just to demonstrate the difference between Omnicide and several common chemistries that we see in use, some of them very old, some of them quite new. Going down that list, you have hypochlorite, iodophores, peracetic acid, formaldehyde, carbolic, what I refer to as quat glute disinfectants, which is a type that we see quite often, which has a very, very high quat content and a very small amount of glute. They do have some benefits. I'm not going to say they don't, but they don't have the full spectrum of benefits that you can get with the optimal ratio of glute and quat. We've also mentioned DDA, bromide, old phenols. Our company has a long history of producing phenols going back, well over 100 years. And finally, chlorine powders there, so calcium hypochlorite. I think it's reasonable to say that the Omnicide formula manages to tick all the boxes. The only thing you can see there is a plus-minus coccidia, which are a particularly difficult class of organism. We do have some efficacy against coccidia, which is unique for a glute quat disinfectant. It's not the same level of efficacy you would get from a dedicated anticoccidial product, but it is there and it is proven. We've done work with the University of Cambridge. We've also done work with Zaragoza University in Spain to demonstrate coccidial efficacy for Omnicide. I've already mentioned a lot of the key features: effective in high and low temperatures, non-corrosive to critical equipment, ability to work with some degree of organic matter, as we saw demonstrated by the DEFRA test results in particular, and the residual activity as well, stretching out to 7 days. The final point to note, and one that people often are surprised by, is that the glute quat disinfectant is biodegradable. That doesn't mean you can take the concentrated product and it will break down very quickly in the environment. It won't. But when you've put it to its in-use dilution, and that then goes into soil or other media, it will naturally break down, and it does meet the European standards for biodegradability. So just to sum up on Omnicide, it's powerful, broad-spectrum disinfectant. We would stand by the claim that it kills more pathogens than any other in the market. We do have proven efficacy out to 7 days residual. And it's reliable for use both in routine disinfection and for remediating farms after a disease outbreak. So, just some basic recommendations on dilution. For walls, floors, equipment, I would recommend 1 to 150 dilution rate. Foot baths, this is for dipping your boots, your footwear. We normally recommend a slightly stronger solution. This is just to make sure you have enough active material in there to get 3-4 days of viable use of the foot bath. Vehicle disinfection, 1 to 150. Aerial disinfection, I've broken this down into some different categories because there's a lot of different equipment used for disinfecting the airspace. Hot fogging requires the most concentrated solution because we work with a very small volume of liquid. And at the other end, misting, which is where we're putting it through a fixed system with nozzles through the shed. We operate at a much more dilute product. And in between, we have cold fogging, which is normally ultrasonic fogging or ultra-low volume fogging systems, where we would typically recommend around 1 to 9. And finally, use for terminal disinfection of water systems. Again, 1 to 150 is the optimum dilution to choose for that type of application. So, just to consider a practical example, and I've picked a poultry farm, particularly a broiler farm, just to work through. Every farm is a little different in terms of its construction, but many of the points here apply no matter what type of unit you're looking at, be a layer farm, be a broiler, be a breeder. You can take a lot of this with some small adaptations to work with any. Broiler farms do present some unique challenges though. Commercial interest, we want to turn that farm around as fast as we possibly can. We don't want the farm sitting for too long. Okay. We have high genetic stock, which also poses a challenge. These birds are built to grow as fast as they can, but to do that, they need to ingest food very quickly. So again, we need to give them the best environment. We have to remember we're trying to combat both known disease challenges, these are things we know are in circulation, and unknown disease challenges. And finally, we have pressure to minimize antibiotic use, which is becoming more and more important. So, to go through reasonably quickly, this is typically what we would do in the UK, and this would represent best practice for UK farms. There are some adaptations. I'm well aware that the practice of recycling litter is quite common in many places, and if that's the case, then I would recommend composting that litter is the best practice to give you a chance. But in an ideal world, you want to remove that litter from the farm at the end of each cycle, clear it all down mechanically, put it onto a truck, take it away from the farm, and very importantly, if it's going on a truck, make sure that truck is covered. One of the worst things you can possibly do is take all that contaminated material, put it on a truck, and send it down the road, spraying particles all over the other farms as it drives by. It's something that happens. I've seen it myself in many cases, but it's always worth bearing in mind. The second stage, pre-cleaning. I'm going to recommend Omniclean, obviously, 1 to 100 dilution. Now, for small areas, you can use a knapsack sprayer. This is just your typical backpack, but ideally you want to be using a high-pressure washer. A foaming lance is the best possible option, and applying that product up the walls, floors, ceilings. But best practice, start at the top, start at the back, and work systematically top, side, and finally floor. So you're continuously channeling the dirt from the top to the bottom and not recontaminating surfaces that you've previously cleaned. Again, ideal, but often difficult if you're under pressure for a quick turnaround. Allow the surfaces to dry. If not, at least remove any standing water from the farm. So use a squeegee or mop or whatever's needed, but get those puddles away from the farm, because if you leave standing water, you're diluting the disinfectant and you're massively reducing its effectiveness if you dilute it. Third stage, your water system. Very important and very often overlooked. You need to clean down the water system thoroughly, disinfect the water system, and refill. One other good practice point, after you've done that, put a low level of disinfectant into the water system so that you hold the bacterial growth up. If you simply empty it after you've cleaned it and leave it part filled, you've got a perfect environment. It's warm, it's humid, bacteria will thrive and replicate in that environment very, very quickly. So a small amount of active material in there will inhibit that growth and ensure that when your new chicks arrive, they've got nice, clean water and not heavily contaminated water to drink. Movable equipment. Now, hopefully all that was removed at the start. You're going to clean, scrub, soak as needed with Omniclean and then use Omnicide. But very important again, when you take that equipment, you've cleaned it, put it in a safe place. Don't leave it standing outside where it can become contaminated, where bird droppings can fall on it and potentially introduce pathogens back into your shed. Get it inside, keep it safe, keep it away from harm. Finally, thermal disinfection. Working with Omnicide, we say 1 to 150 to 1 to 300. 1 to 150 is optimal for the typical temperature ranges we see in Argentina. If you were talking about very, very hot countries in the Middle East, you can go up to 1 to 300 dilution. But for here, 1 to 150 is the perfect dilution to cover you through the summer and winter periods. Again, use a knapsack sprayer, or for larger areas, use a pressure washer. The important point, though, you don't want a lot of pressure. Just a gentle pressure is ideal for putting a disinfectant on. Or, better still, use a foamer to maintain the disinfectant on the surfaces for the maximum amount of time. I do mention for the floors, you need to consider the surface you're looking at. If you've got a good concrete floor, non-porous, or at least reasonably non-porous, you can use 100 mils per square meter. If it's quite a poor quality floor, you want to increase that around 300. And the worst case, if you have earth floors, you do need to go to a much stronger dilution for those, because you've got an enormous amount of soil there. It's very, very difficult to disinfect soil. Obviously, pay particular attention. Corners, cracks, seams, wood, concrete, all these things are more difficult to disinfect. Make sure they get a good covering. And as with cleaning, work systematically. Work from the top down, from the back of the building to the front of the building. Finally, allow your surfaces to dry before restocking. I'm going to mention one final stage, which has become best practice, certainly in the UK and across Europe, and that is to fog the building after it's been set up. So this is the point where you've put your chick paper down, you've got your shavings down, or your other bedding materials are in place. Everything's there, drinker lines are down, feeders are there. If you fog the building through, you've got two benefits. One, you capture any spaces that were missed in the initial disinfection. And this is particularly relevant for ventilation systems and other things. You're never going to get much disinfectant into those spaces by spraying. If you fog, you cover all of those spaces, and that will have a definite real benefit in terms of your productivity on the farm. Once you're done, 24 hours is a good interval between final fogging and introduction of animals. You can do it at a shorter time. You can take it down to 3 hours, but ventilate the building properly before you go in. Just keep the atmospheric glutaraldehyde levels at a comfortable level for both operators and the livestock going in the building. I'm going to finally mention foot baths. And I'm going to say this is probably the most abused item I ever see on a farm. Foot baths are put in place, hopefully, at all the entry points to buildings, and then they're left to do what they do. People jump in them with boots that are covered in mud or bedding or other things contaminate the footbaths, you're achieving nothing by doing that. The best practice with a footbath: scrape, brush the boot, wash the boot off with some clean water, and then into the disinfectant. That way, your disinfectant has a fighting chance of doing what you want it to do, which is disinfecting your boot and preventing you from taking pathogens from outside a building into the building, or from one building to the next building. So pay attention very much to that particular area. Finally, wild birds and animals. It's very important to exclude these from the sheds. These can track all kinds of pathogens, both from within your own farm and from outside your farm. I'm thinking of rats or wild bird life, insects. All of these have the potential. All of them need to be considered and control measures put in place. So, just to sum up, good management and biosecurity, in my opinion, can dramatically reduce the cost of disease on a farm, improve the quality of production, profitability, and also animal welfare. So at that point, I would like to say thank you to everybody for listening, and if there are any questions.